recording. Okay, guys, so if y'all remember last semester, I introduced you guys to vectors. We're going to elaborate more on vectors today, but we're going to apply trigonometry to vector analysis. Okay? That is the goal for today. Okay, I'm just going to go over just a few examples with, well, I'm going to go a lot of examples with you guys, just to be sure you guys have enough information to be able to do this assignment on your own. So, if you click on the folder for today, today is February the 1st. It is a Monday. So we're going to go over the rules for how to add vectors graphically. Then I'm going to do some sample problems with you guys in this vector analysis PDF file. And then I'm going to leave you guys on your own to do the vector assignments. The vector assignment that is currently uploaded in Schoology. And I'm going to make available to you guys as soon as we get done with this. Okay. So if y'all remember last semester, we talked about vectors, and basically we said a vector is a mathematical quantity represented by an arrow that has both magnitude and direction. Does that sound familiar to you guys? Talking about vectors. Vectors have magnitude and direction.
Yes.
All right. So, hold on, guys. So, if y'all remember, I taught you guys how to draw a vector. For example, like let me pull up a new blank page. No, I want a graph page. Hold on, let me pull up a graph. So remember, I taught you guys how to draw a vector. Okay, and again, I'm trying to go over this review stuff pretty quickly so that I can get to the meat of the topic for today. So, guys, how do you draw the vector? Let's say I want to draw the vector -4, +5. Do y'all remember how to draw this vector? So remember, whenever you're drawing vectors, you can start anywhere on your graph. You can start drawing it anywhere. So what this is saying is, if I decide to start from this point right here, I will count 4 units to the left, 1, 2, 3, 4, and I will go 5 units up. 1, 2, 3, 1, 2, 3, 4, 5. So this is my ending point, and then I would draw my arrow like this. So that arrow that I just drew in red, that is the vector -4, 5, because I went 4 units in the x direction and I went up 5 units. So hopefully this is ringing a bell and everybody remembers this. Now, one of the things we went over, thank you, Angelina. One of the things we went over last semester is that we talked about how to add up vectors mathematically. So if I give you guys 2 vectors, let's say I give you this vector right here, 2, 5, and I ask you to add that to the vector 1, 3. Okay. Guys, whenever I add up these 2 vectors mathematically, what do I get?
Is it like 3, 8?
It's what?
3, 8.
Yeah. So when I combine those two vectors, it has an x component that is 3, yes, and a y component that is 8. Thank you, guys. 3, 8. So again, we talked about all this last semester. This is how we add vectors mathematically. We just combine the x components and we combine the y components, okay, to get our resultant vector. So we've already talked about this. Y'all know how to do this. What I want to focus on today, I want to focus on how to add vectors graphically. I know you guys know how to add vectors mathematically, but I want to focus on how to add vectors graphically. In other words, suppose I give you a visual representation of certain vectors, but I don't give you their x and y components, and I ask you to figure out how those vectors are going to look like. That's what I want to focus on today, how to add vectors graphically. So in other words, let me start a new page here. Okay, guys, let's suppose I give you a visualization of two vectors. Let's say I give you this vector right here, v1, that looks something like this. So this vector in purple right here, we're going to call this vector v1. And then I give you a vector in blue here that we're going to call v2. Okay. And now, I don't tell you what those x and y components are. I just give you a basic visual of those vectors, but I asked you to add up those vectors graphically. How would you do that? So in other words, if I could take v1 and add it up to v2, what I get the vector v3, which is the sum total of v1 plus v2. Okay. So how do we do this? How do we add vectors graphically? This is what I want to focus on today. Okay. So there are 3 steps that involves you guys adding vectors graphically. Okay. In other words, how to combine these arrows to visualize how the resultant vector is going to look like. So step 1, you're going to connect your vectors head to tail. Okay. Step 2 says basically you're going to find your starting point and find your ending point. Okay. Step 3 says draw your resultant vector pointing from the starting point to the ending point. Okay. Let's look at this briefly. Okay, so I have 2 vectors here. This is v1, this is v2, and I want to add them graphically. Okay, so in order to do that, step 1 says I want to take my vectors and I'm going to connect them head to tail. So guys, this is how you do this. You basically take the tail of one vector and you combine it to the head of another vector. So something like this. So notice what I did here. Hold on, guys. Okay, there we go. Okay, so that's step 1. I connect my vectors head to tail. So notice I took the head of the purple arrow and I connected to the tail of the blue arrow. That's step 1. So basically, you guys, you chain your vectors together. That's step 1. So step 2 says to find the head of the chain and find the tail of the chain. In other words, find both the ending point and the starting point. So guys, imagine this right here was a trail and you were, following the arrows to walk home. Well, if you were walking home and you were following the arrows, this right here will be your starting point. And then if you follow the arrows, you will walk like this and you walk like this. This right here will be your ending point. So that's basically step 2. Once you combine your vectors, you're going to find a starting point and you're going to find an ending point along that chain. Okay. Then step 3 says, draw your resultant vector from the starting point to the ending point. So basically, guys, we're going to connect these dots. In step 3, we're going to draw a resulting vector from this point all the way to that point. Okay. And so, guys, that arrow that I just drew in red, that is the vector v3. In other words, whenever we combine vectors v1 plus v2, we get a visual that looks like this, which is v3. So that's what I mean when I say add vectors graphically. We're just getting a visual of how the resultant vector will look like, even if we don't know the specific x and y components. Okay. So let's do another example. The more examples we do, the better. Okay. So suppose I give you a vector that looks like this. Suppose I give you a vector that looks like this. I'm going to call this vector right here v1. Okay. And I'm going to call this vector right here v2. And I ask you to combine those two vectors to get the resultant vector of v3. So v3 is a combination of vector 1 and vector 2. Okay. So if I was to add up those two vectors, what would the resulting vector look like? Okay. So remember, step 1 says take the tail of one vector and connect it to the head of the other vector. So in other words, you're going to piece them together like a chain. And then step 2 says find the head of the chain and find the tail of the chain. In other words, find both the ending point and the starting point. Step 3 says draw your resulting vector pointing from the starting point toward the ending point. Okay, so let's do this. So step 1, we're going to take these two vectors here, and we're going to combine them head to tail. So in other words, I'm going to take this right here. I'm going to take the tail of one vector and put it on the head of the other vector. Okay, so that's step 1. Step 2 says basically find your starting point and your ending point. So guys, once you connect these two arrows together in a chain, you're going to link them together. Remember, the starting point would be this point right here, and the ending point is where the arrows point to. So the arrows ultimately point to here. So like if I had to walk this trail here, I will go like this, and I will go like this. I will follow the arrows. So this is my starting point. This is my ending point. So that's the starting point of my chain. That's the ending point of my chain. Okay. Then step 3 says draw your resultant vector pointing toward the ending point. So in other words, I'm going to connect these two dots. When I connect these two dots, and the arrow, guys, has to always be pointed towards your ending point. So this right here in red, if you look at that arrow in red, that arrow in red, that is the vector v3. In other words, when we combine vectors 1 and vector 2, that's what we get. Make sense, guys? Let us do another example. Suppose I give you an arrow that looks like this. I tell you that this right here, let's say I give you an arrow that looks like this. We're going to call this right here, we're going to call that arrow right there v1. Okay. Suppose I give you another arrow, green, an arrow that looks like this. And we're going to call that arrow v2. And I ask you to combine those arrows. To get the vector v3. And v3 is a combination of vector 1 and vector 2. So when we add those two vectors, how do you think the resulting vector will look like? So remember, guys, the step one says to combine your vectors together like in a chain. In other words, link them together. You want to link them together head to tail. So let me ask you guys a question. Whenever I'm linking my vectors together, can I link them together like this? Is that legal according to the first rule? Can I link them together like that?
No.
No, because if you notice, that's head to head, right? So I've seen students do that. You can't do that. That's illegal for the first rule. What about like this, guys? Can I for the first rule, whenever I'm linking them together? Let me see. Can I do that? Can I link them together like that? Exactly, Angelina. You can't do that because that's tail to tail. No, you have to link them together head to tail. And guys, it doesn't matter which one of them you move. You can move the blue one or you can move the green one. It doesn't matter which one you move as long as you link them together head to tail. You're good. So, can I do that? Can I link them together for step one?
Yeah.
Yeah, this you can't do that because again, it's head to tail. So that's legal for the first step. Now, step two says find your starting point and your ending point. In other words, you're finding the starting point of the chain and you're finding the ending point of the chain once you link them together. So remember, you always follow the arrows to reach your ending point. It's kind of like if you were following directions and you were following a trail and you were looking at the arrows. You would start here, you will walk like this, and then you'll go like this. So this is the starting point of your chain. This is the ending point of your chain. So that's step two. We found our starting point and we found our ending point. Now, lastly, step three is to draw your resultant vector from the starting point toward the ending point. So that arrow that I drew in red, that is referred to as the arrow V3. So when we combine the vectors V1 and V2, that's what we get a vector that looks like that. It looks like a V3. Okay. Now, someone in my last class asked me, like, Mr. Taylor, when you drew V3, you connected the two heads. I thought you can't do that. That's illegal. Well, guys, whenever I'm saying you're connecting them head to tail, that's basically for your first step. Whenever you're linking the chain, whenever you're linking them together like in a chain. However, whenever you're drawing V3, you do draw the arrow pointing toward the ending point. So in other words, yes, whenever you're drawing your resultant vector, yes, this arrow and this arrow will touch. But whenever it comes to linking them together for the first step, that's when you combine them head to tail. Again, in case anybody was thinking it, I just want to be sure that I answered that correctly for you guys. Therefore, there's no confusion. Now, yeah, Angelina, from basically in the third step, those two heads will touch because in the third step, whenever you're drawing your resulting vector, it is going to point toward the ending point. Yes. But Angelina, what I'm saying is for that first step, that's when you're focusing on linking them together, head to tail, head to tail, head to tail. You got that? Okay, awesome. But yeah, on that very last step, you will have two heads touching, because that's where you're actually drawing your resultant vector. And guys, these same rules apply not only when adding up two vectors, but these same rules apply whenever you're adding 3 vectors or 4 vectors or 5 vectors or 6 vectors, 7 vectors. You can add up as many vectors as you want. So for example, I could give you something like this. I can give you one vector that looks like this that we're gonna call V1. I can give you another vector that looks like this that we're going to call V2 is, yeah. I can give you another vector that looks like this. Then I'm gonna call this vector right here V3. I can even give you another vector that looks like this. Let me see. That I'm gonna call V4. So I have four arrows there, and I ask you to find the resultant vector basically the resultant vector is whenever I add up V1 plus V2 plus V3 plus V4. So if I add up all four of these vectors, how would my resulting vector look? Y'all think I can do that? Or y'all will add up all those arrows? Okay. So remember, guys, the same rules apply whenever you're combining vectors. And by the way, guys, just so y'all know, y'all are going to be working on this in Mr. Becksmith's class at the end of the semester too, because they focus on vectors in pre-cal. So, guys, whenever you're adding vectors, a bunch of vectors, you just follow the same rules. Step 1, connect your vectors in a chain, like head to tail, head to tail, head to tail. Okay. Yes, Angelina, this will be in pre-cal too. Yes, it sure will. But not until like close to the end of the semester when you guys get to vectors. It's either midway or end of the semester, depending on how far along Becksmith is. In fact, Angelina, next time you're in Becksmith's class, ask him when are you guys going to work on vectors. Tell him Mr. Taylor just wanted to know. Okay, because I'm just curious when he starts on vectors. All right, so again, guys, thank you. Whenever you're adding vectors, you always want to connect them head to tail, head to tail, head to tail, head to tail. So let's do this now. So, can I do this, guys? Is that a legal move for this first step?
No.
Nope. How about that?
No.
Yeah, I can do that.
Oh, okay.
Yeah, because like notice this right here. So, and hold on. Yeah, this I can do because notice that's head to tail. Okay, now let me do my other arrow. So this like this, head to tail, and then like this, head to tail. Okay. So everybody follow me what I did? I just combined all of my vectors. I basically I added. So I basically made a chain. So that's step 1, head to tail, head to tail, head to tail. So I just made a chain. That's step 1. Okay. Now step 2 says find your starting point and find your ending point. Okay. Remember, guys, in order to find your starting point and find your ending point, just follow the arrows. Follow where all the arrows point to. So, if I had to follow along these arrows, I would start here, and I would go like this, go like this, go like this, and then go like this. So notice that's my that's my ending point. So this is my starting point, and then this is my ending point. Okay. So that's step 2. Find my starting point, find my ending point. And then lastly, step 3 says to draw your resultant vector pointing toward the ending point. Let me ask you guys a question. On step 3, whenever I'm drawing my resulting vector, can I do that? Can I do that? Should my arrow be pointing like that? Is that right or wrong?
I'm pretty sure that's right.
Ooh, is that pointing toward my ending point?
That's what it has to do.
Yes, it has to point. It has to point toward your ending point. Yeah. So in other words, whenever you're drawing your resulting vector, it points like this, right? Because we started here and we ended here. So that's how this looks like. So this is how my resulting vector looks like in red. Makes sense? Oh, and Angelina, one thing I want to say, whenever you're combining your vectors, it's not going to always look like a triangle. You know, um, you can have four arrows that looks like this and combine it and it looks like a square. I mean, that's possible too. Or yeah, so it's not going to always look like a triangle. Sometimes it might, sometimes it might not. As, you know, sometimes you can have a lot of vectors and you can add them together and the shape just looks weird. Yeah. I want to do one more example. Um, what if I had something like this? What if I had a vector that looks like this? Oh, wrong color. What if I had a vector that looks like this? Um, a vector that looks like this, and I had a vector that looks like this. So guys, suppose I gave you these three vectors and I asked you to combine all those vectors to get the resultant vector. So in this case, guys, I'm going to call my resultant vector V4 because V4 is basically a combination of V1 plus V2 plus V3. So if I was to add up these vectors, how would this look like? Okay, remember, step one, combine your vectors head to tail, head to tail. Guys, you're basically linking them together like a chain. That's step one. You're linking them together like a chain, head to tail, head to tail, head to tail. So let's link things together for step one. So can I do that? Is that okay? Link it together like that?
No.
No. What about like this? Can I link it together like this?
Yes.
Yep.
It's like a car accident. You're not supposed to hit him head on. You're supposed to hit him in the back.
Okay. That's an interesting way of thinking about it. I never thought about that before. I like that though. I like that. Okay. And then lastly, I'm gonna connect this like this. Okay. So y'all see that? So I connected all of my
What is
arrows.
that?
Yeah, I connected all my arrows head to tail, head to tail. So I linked them together. That's step one. Okay. Step two is to find your starting point and find your ending point. Remember, guys, if you look at the arrows point toward your ending point. So, you know, so imagine this was a trail. Like I was in the wilderness and I was walking a trail and I was following signs. I was following arrows. I would start here and I would walk here and I would walk here, then I would walk here. So this would be my starting point. I would start here. And I would walk along, and ultimately I would end up here. Okay. Y'all see that? So I labeled my starting points and I labeled my ending points. Then lastly, the step three is to connect the dots. Basically, draw your arrow pointed toward the ending point. So in step three, so that arrow, guys, if you look at that arrow in red, that is our resultant vector that I'm going to call V4. Y'all got that? Make sense?
Yeah. Looks like an hourglass.
Yeah, it looks like a weird looking hourglass. Like I said, don't pay attention to the shape. The shape is not what's important. What's important is that you guys get the rules. Okay. Uh, so hopefully everybody understands how to add vectors graphically. Okay. So, guys, on this assignment that I posted in Schoology, there's like one or two questions where you have to add vectors graphically, and don't worry, and I made it easy. I made it easy where you can easily look at it and kind of see, like, what would happen if you combine them head to tail, and you can see how the resultant vectors is going to look like. So I made it pretty easy, at least in my mind. I made it easy. And so you're going to have to be, for this assignment, you're going to have to add vectors graphically. There's some problems where you have to add vectors mathematically. There are some problems where they give you the x and y components and they ask you to find the magnitude. And other problems, they're going to give you the magnitude and ask you to find the x and y components. Angelina, no, you won't have to. You can just kind of eyeball it. I tried to make it easy enough to where you can look at it, and if you remember the rules, you can be like, oh, okay, I got it. I got that. I tried to make it as simple as possible because it's going to be multiple choice, and I tried to make it where you can eyeball it. During a normal school year, we would work on this in class, but I don't want to take up too much of y'all's time. So let me just do a few problems on here involving calculating vector magnitude. Okay, so guys, suppose I give you a vector that looks like this. Okay, look at this arrow here. Suppose I give you that vector and I ask you to find the magnitude of that vector. Remember what magnitude means. Magnitude means the length of the vector, how long it is. Can someone tell me from last semester, how do we find the magnitude of a vector if we know its x and y components? Anyone want to tell me? Anyone remember?
You repeat the question.
So how do I find out how long this arrow is? How do I find the magnitude? How do I find the magnitude of this vector if I know its x and y components? Who remembers that? We talked about this last semester, how to find magnitude of vectors. Anyone want to tell me? Makayla, I know you know this because you shouted it out last semester. So you should know this.
No, I still don't know how to say. I know it's Parag. Parag. I can't say it.
Say it again.
I can't say it. I literally can't say it.
Okay, and you getting on me for four, and you can't say Pythagorean
theorem. Yeah.
Okay. No, I'm just messing with you. Okay. So yeah, you would use Pythagorean's theorem. So do y'all remember this? Stephanie, guys, y'all remember talking about this last semester?
Are we supposed to like put the square root x squared plus y squared?
Yes, exactly. Yeah, exactly. So like first of all, you need to write down the x and y components first. So what you want to do is you want to count how long the vector is in the x direction and how long the vector is in the y direction. And y'all should know how to find this. Basically, you count the squares from this point to this point. So in other words, so let's see. So I'll go 1. So I go 1, 2, 3, 4, 5, 6, 7. Okay, so I move 7 squares in the x direction. Now, how many do I move in the y direction? 1, 2, 3, 4, 5, 6, 7. Okay. So clearly this vector here has an x component that is 7 units long and a y component that is also 7 units long. Okay. So once I know how long the x component is and how long the y component is, I can easily find the magnitude of this vector. And y'all should know how to find the magnitude of the vectors. You just use a squared plus b squared equals c squared. So you would use Pythagorean's theorem. Okay, so it's just 7 squared plus 7 squared equals c squared. Okay. So y'all should know how to solve this equation for c. 49 plus 49 is equal to c squared. So in other words, 98 is equal to c squared. And guys, how do I get rid of the squared? Anyone?
Square root.
Yep. So the square root of 98. Okay, that gives me 9.9. So the magnitude of this vector is 9.9 units long. Okay. Makes sense? We need to do another example. Let me see. Which one do I want to do? Let me see something. Let me see. Let's look at this arrow right here. Okay. So suppose I give you this vector here, and I ask you to find the magnitude of this vector. Remember, guys, you can easily find the magnitude of a vector if you know its x and y components. Remember, guys, magnitude just refers to how long the vector is. So that's what magnitude means. When I ask you to find the magnitude of a vector, I'm asking you to find how long this arrow is from here to here. Okay. And guys, whenever you're finding how long the vector the vector is, remember you want to count the amount of squares between this point and this point. Okay, that's the first thing you want to do. So let's see how many squares we move in the x direction. So we go 1, 2, 3, 4, 5, 6. Okay, so we move 6 units in the x direction. Okay, and then from there we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so everybody see what I did? So I went 6 units in the x direction, and I went 8 units in the positive direction. So this vector here has an x component of 6 and a y component of 8. Okay. Now, y'all can easily find the magnitude of this vector. Okay. In other words, what I'm saying is you can easily find out how long this vector is from here to here just by using Pythagorean's theorem. Once you use Pythagorean's theorem, which is just a squared plus b squared equals c squared. So I'm doing it now. So 6 squared plus 8 squared equals c squared. Okay. Once you solve that equation for c, you can easily find out how long that vector is. And I'm going to do that now. 6 squared plus 8 squared. That's equal to 100. And then so basically 100 divided by, the square root of 100. When I solve this equation for c, I get 10. So what that tells me, guys, so that tells me that this vector has a length of 10 units. So the distance from here to here is 10 units. So that's how I find the magnitude of a vector. Okay. So everybody got that, guys? On your assignment, guys, whenever it asks you to find the magnitude of a vector, you get your x and y component first, and then from there, you just use Pythagorean's theorem. From there, you just use Pythagorean's theorem. to find the magnitude. And guys, don't forget, vectors can also have negative x and y components. For example, look at this vector here. So I want to figure out what is the x and y components between this point and that point. So here I'm going to move 1, 2, 3, 4, 5, 6 units to the right, and then 1, 2, 3, 4, 5, 6 units down. So this vector right here has a magnitude of +6, -6, right? Because I moved to the right, but I moved down, and remember, down is negative. So, but whenever you're finding whenever you're using Pythagorean's theorem to find the magnitude, you just keep your numbers positive, because remember, anytime you square a negative times a negative is a positive. Just something to keep in mind. Okay. All right. Now, the last thing that I want to talk about before we end the day. Okay. So, you guys in here already know how to find the magnitude of a vector if I give you the x and y components. But guys, suppose I go backwards. Suppose I give you a vector and I give you its magnitude and I ask you to find the x and y components. What would you do there? So, for instance, guys, suppose I give you a vector that looks like this. Let's assume. What do I want to do here? Let's assume I give you a vector that looks like this. I give you a vector. This vector looks something like this. I can draw an arrow better than that. So I give you a vector that looks like this, and I tell you that this vector has a length of 15 units. I also tell you that this angle right here is 67 degrees. Someone tell me, guys, if I give you this information and I ask you to find the x and y components of this vector, how would you do that? Anyone got an idea?
Would it be?
I can't hear you. I'm sorry.
Can you repeat that?
I'm asking if I give you a vector, I give you its direction, and I give you its magnitude, and I'm asking you to find the x and y components of that vector. How will we do that?
Wouldn't it be a right triangle?
Exactly. So what will we use, Tiffany, for that?
I would use something from like pre-cal that I learned, but I don't know if that's what we would do in this case.
Yes, you would use SOHCAHTOA.
Yes.
Exactly. You'll use SOHCAHTOA. Exactly. So everybody got that, guys? So whenever I give you a vector, I give you the magnitude and ask you to find the x and y components, you're going to use SOHCAHTOA. Okay. So before I work this out, I'm gonna repeat everything that I just said. In this example right here, I gave you the x and y components and I asked you to find the magnitude. Whenever I'm asking you to find the magnitude, you will use Pythagorean's theorem. However, when I ask you to go backwards, when I give you the magnitude and ask you to find the x and y components, that's where you will use SOHCAHTOA. Because in other words, notice how this vector here, okay, this vector here clearly, it clearly has an x component, okay, and it also clearly has a y component. And I'm sorry I'm not drawing these lines perfectly, but y'all get the point. So we have an x component, and we also have a y component. Okay. And again, we're assuming this angle here. We're assuming this angle here is 67 degrees. Okay. Someone tell me, how do I find the x component? Do you think, am I going to use sine or cosine? What do y'all think? Anyone?
Okay, so you have the hypotenuse and the.
So for the,
I'm guessing that's the adjacent.
That's the adjacent side, and the
So
hypotenuse.
would it be sine?
Say that again.
Would it be sine?
No, sine is for the opposite side.
Be cosine?
Cosine, exactly. You got it. So cosine, so you would say cosine of 67 degrees is equal to x over 15. Okay. And everybody should know how to solve this equation for x. I'm not gonna, go through the algebra there because we did that last week. Okay. So that what does that mean, Jeremiah? If I want to solve for y, what would I use then?
You would use the tangent.
Well,
What do you mean solve for y?
Well, I take it back. You could once you found x, you could, but what if I wanted to relate this side to the hypotenuse? Then I would use sine.
Sine, yeah.
No, but you're right. If you wanted to use tangent, you could. If you already solved for x, you could do that if you wanted to.
Oh, okay.
Yeah. But if I'm relating the y component to the hypotenuse, I would do that. And y'all know how to solve this equation for y. Let me draw a better looking y. Okay. Any questions, guys, on that? So on this assignment, guys, whenever I ask you to find the x and y components, you're going to use SOHCAHTOA to solve. In this case, you're using cosine to solve for x, and using sine to solve for y. And then, you know what? Let me go ahead and do the calculations on this so I can just give you guys the answers. 15 times cosine of 67. That gives me 5.9. If I do 15 times sine of 67, that gives me 13.8. So of course, let me go ahead and bracket that. Okay. So guys, there you have it. That's my answer. I just found my x and my y components using sine and cosine. Okay. Guys, any questions? Do I need to work out another example of this, or y'all got this down? Y'all feel pretty good about the trig? Y'all good? Okay. So hopefully everybody got that. So just remember, whenever you're whenever you have the x and y components and you're asked to find the vector's magnitude, that's where you use Pythagorean's theorem. If I ask you to go backwards, where I give you the magnitude, and I ask you to find the x and y components, that's when you're going to use SOHCAHTOA, sine and cosine. Okay, guys, if y'all don't have any immediate questions for me, you guys are free to go. I'm going to keep the Zoom call open up in case someone wants me to stay on and work out some additional problems. But other than that, you guys are free to go. Bye, guys.
Bye. Have a great day.
Bye, Angelina. Take it easy, okay?
What is the homework?
Vectors. Hi, Makayla.
So like it's like a edu puzzle.